it's going to be really important that when we start looking at some of these rules today, you have them written down correctly so that you can refer to them, because there's really no rhyme or reason to some of this. You're just going to have to make sure you understand why rules work the way they do, okay? So in 5.4, properties of logarithms, have a volunteer to read our question that we're trying to answer today. Thank you, Sam.
How can you use properties of exponents to derive properties of logarithms?
Yeah, so guys, we know from the past, we know that if I have something like e to the x is equal to some value y right here, how do I turn that exponential equation into a logarithmic equation? How would you write that? Okay, yeah, I could say natural log base what, kids? E of some value y would equal what here? X, you bet, okay? These here mean exactly the same thing right there. That's what we've talked about in the past right there, okay? Now, if I would have used a base other than e, instead of using natural log, I would have probably used a common logarithm. So it doesn't really matter which one we use. We use natural log when the base is e, and then other bases for logs that typically are 10. So how can we use these properties to come up with new properties of logarithms? So in order to answer this question, first of all, we're going to have to use the properties of logarithms to, what's the word here, kids? Evaluate logarithms. We want to do that. We also want to use properties of logarithms to expand or condense expressions. Okay? And then we're going to use what's called the change of base formula to evaluate logarithms. I've got news for you. You've already used change of base formula. Let me write this down quickly over here on the left. If I asked you guys to evaluate this on a quiz yesterday, log base maybe 3 of, I don't know, 81 right here. Do you guys remember how you punched that in to solve that? How'd you do that, Jasmine? Log of 81 in your calculator over. Yep, okay. And that really is a change of base formula that I kind of got to earlier to make life a little simpler for you, but that's kind of really what we're talking about. So, kids, I don't really have much in terms of vocab today. You know what a base is, right? Okay. In two forms right up here. If I have maybe b to the x equals y, which variable is your base? B is, right? If I write this as log base b of y equals x, what's your base again? You know this already, okay? Properties of exponents. Okay, listen to what I say about properties of exponents. Not going to go through all of them right here, but if I have, well, I guess I can. A to the m times a to the n. If I'm multiplying like bases, what do you do with exponents? You add them, okay? If I add a to the m divided by a to the n, like so, what would you do with exponents here? Subtract. If I add a to the m all to the n power like this, what would you do with exponents? When there's parentheses like that, you're bringing one exponent into another. What would you do? Multiply. So those rules are going to apply. Those rules are going to apply to what we're looking at today. So let's start working on our new properties right here. I'll leave that up there so you can get that down. Okay. But core concept, 3 properties of logarithms that we're going to start with. Okay. Are you ready for this? Smile and say, yes, Carson, we're ready.
Oh, okay.
I'm sorry, Sam. What do you got, kiddo?
I couldn't read your A.
Oh, it's an A. Yeah, this pen, it's not the best. I just maybe need to slow down a little bit with it. Hang on a second. Now you be good. Maybe that helped. Think? All right. This is a big idea right here today. Pretty important stuff here. So make sure you get this down. This is pretty important right here. Okay, big concept right here. Core concept, properties of what, kids? Okay, this is going to be really important to understand. All right. First of all is a product property, which states this. If you have log base b of some value m times n, this is the same as log base b of m plus what? Okay. It's kind of like saying if you have e to the m times e to the n, you would add your exponents. So as an example right here, if I had maybe like this, if I had log of, oops, didn't want to do that. Let me blow this up quickly. If I had maybe an example like this, maybe I have the log of, help me think of a number, kids. Give me a number between 10 and 99. I'm going to go 21. I like 21. I heard that first. 55 would have been a good example too. Okay. Okay, here's the deal. Log, I didn't put a base up there, so really what base is up there, kids? Okay, the base is 10. Okay. My question to you is this. Can you think of two numbers that multiply to 21? 7 and 3. Okay, this would be the same as the log of 7 plus log of 3. Okay? So numbers that are products can be broken down. If you have the log of some number, it can be broken down as the log of a smaller number plus the log of another number, as long as those two numbers multiply to the initial one. Who has a calculator handy, by the way, for me? In your calculator, do this. Do log of 21 in your calculator and give it to me to, let's just go 2 places today. What is the log of 21 when you type that in?
1.32.
Okay, now in your calculator, do log of 7 plus log of 3. Log 7 plus log 3. 1.32 again, right? Same thing. So, as an example, let's just say I wanted to write, over here on the left, if I wanted to write the log of, I don't know, 90 as the sum of two other logarithms. Give me an example that would work. 9 and 10. Log of 9 plus log of 10. Okay? So guys, product property says right here, if you have log of m, n, right here, and assume that there's what around the m and n here, kids? Parentheses, that's the log base b of m plus the log of n. So if the product property of logarithms means split it up and add logarithms, what do you think the quotient property of logarithms is going to mean? And isn't that kind of the same way as exponents? If you divide exponents with the same base, what do you do with exponents? Subtract. So it's kind of the same thing. So let me give you an example here. Maybe I have the log of, I don't know. How about the log of 200? Is that okay, kids? Okay. Can you think of a quotient that would get you to 200? Maybe like 400 divided by 2, or maybe 1,000 divided by 5. Is that okay? Okay, because the log of 200, I might say this is the same as the log of, I'm going to go log of 1,000 minus log of how much, kids? 1,000 divided by what would make your 200? Okay, agree with that? So think about it this way. Punch in log of 200 in your calculator. .3. Okay, what's the log of 100? Or I'm sorry, 1,000 in your calculator? So you've done this all again. Log of 1,000 minus log of 5 is 2.3 again. Okay. All right, let me ask you this question then. 2 questions actually. If I had the log of 7 plus the log of 6 right here on the left, what would that equal as a single logarithm? log of 42. You would take 6 times 7. That would be the same as the log of 42. What if I had this? Log of 20 minus log of 4. What would that be as a single logarithm, kids? Log of 5. Okay, good. I think you had that. All right. So then the last one down here, kids, is the power property. And I think that of the 3 that are up here, I think the first 2 are common sense because they relate to properties of exponents really well. But the one that I think is really important right here, kids, what's it called? Power property of logarithms, okay? This one here is going to save you a lot of time, so make sure you understand this one, but this is really important. This says, guys, the following. If I have log base b of m to what power? N, this is equal to n times the log. This should be base b, so maybe I screwed that up. So maybe make sure you understand this is a base. It should have been down here, like so. This is log base b m times n. Where does this exponent really move to then, basically, kids? Where did that move to? Yeah, it moves out front, really. Okay? So if I had something like this, if I had log of, I don't know, maybe x to the 3rd power right here, this would equal, where can I move that exponent, kids, according to that rule? Out front. So this would be 3 times the log of what? 3 times the log of x, okay? This rule, highly important, okay? Those rules are going to be completely relevant here to what we're doing here. So kind of working backwards of exponentials using logarithms. And of the 3 core concept logarithms right here, which one's going to be the one that helps us a lot? Property of power, okay? Property of a power. These 2, they relate really nicely to the exponents, okay? And then this power right here, it's really going to be what we need to understand to be successful. So let's move on this right here. Do you guys have the rules in here? Everybody have an example down like we have over here on the right that applies to this? Okay. Give me a thumbs up if you're ready to roll on. All good? Okay. Let me size this down quickly. So example 1, let's talk here, kids. It says using properties of logarithms, and I've got to get rid of this right here. So where are my tools? There they are. Drag them over here. Okay. Whoa, I didn't want to do that, but this will work. All right. Guys, right here, example 1 says, use the idea that the log base 3 is what? I'm telling you, log base 3 of 4 is approximately what? Yep. And they're telling you that log base 3 of 5 is approximately what? Okay. It says use property of logs to try and evaluate this. I don't even want you to punch the word logarithm into your calculator when you do this. You'll need a calculator to do it, but I don't want you to punch the word log in there, okay? We have this idea right here that this value is this and this value is this. Guys, they want you to evaluate log base 3 of 4/5. Ideas or thoughts on how you would do that? Let's see, is this a product? Is it a quotient? Or is it a power? It's a quotient. So I would use the quotient property, which says log base 3 of 4/5 is equal to what minus what? And gave it away there. How would you rewrite this, kids? Use your middle one, which states right here, log base m over n is the log of m minus what? I hear lots of whispering. I can't hear you guys. What are you saying? Yeah, log of m minus log of n. Okay, so how would I write this using these values down here, kids? Log base 3 of 4 minus. Well, kids, what is log base 3 of 4? And what is log base 3 of 5? So you're just simply going to go 1.262 minus 1.465 there. Somebody run that for me quickly and see what you have. Negative point 2. Is it negative 0.203?
Yeah.
Okay. All right, so I want to see what you guys come up with. I want you guys to see if you can't use these two values somehow to formulate this. And see if you can come up with the number for that. By the way, in your calculator, you guys have your calculator? Never mind, because it's log base 3. I don't want that. I'm just going to leave it as is. I want to see what you guys get for values here. You guys try to next to on your own. See what you get.
My book or my calculator has a sheet to it.
So it's just a bunch of them log base 3 of 4/5 and see if that's actually true. Anybody have the second one? Anybody want to tell me how you can use log base 3 of 4 and log base 3 of 5 to form log base 3 of 20? Jazzy, you want to help me with that?
Yeah.
Okay, so what was your thinking or what was your logic behind that?
So like in order to do those, we have to find the numbers from 4 and 5.
Okay, so we've got to figure out how to use these numbers right here, the 4 and the 5, to get to what, kids? Well, 4 times 5 is 20, so we can use them, but by logs of the, did you say multiply?
Well, like the two numbers have to literally add.
So we're going to use the product property, right?
Yeah.
So we have to call log base 3 of 20 equal to really what here?
Log base 3 of 4
Okay,
plus log base 3 of 5.
good. So I can use these values now. What's the equivalency for log 4 here?
1.262.
1.262 plus,
1.465.
okay, so let me exercise my north of Highway 3 math skills. That's a 7, that's a 2, this is going to be a 7. I'm getting 2.727. Does that look right to you, Jasmine?
Yeah.
How many had 2.727 there? Awesome. Okay. All right. Hey, how about log base 3 of 25? How can I use the 4, the 5, or a combination of stuff to formulate 25 given what we have up there? I can only use log base 3 of 4 and log base 3 of 5. Yeah, use 5 twice. 5 times 5 is 25. So, Xavier, if I understand you correctly, it looks like you want to call this, am I adding or subtracting, kiddo? How many agree that 5 and 5 would make 25? And by rules of the product property, this would be true. So this is going to become what plus what, kids? Oh, what is that, 2.93?
Yeah.
I love it. Okay. Do you guys get the rules so far? Everybody understand those first 3 on example 1? Are we happy with that or okay with that? Okay. Questions so far? All right, here we go. Second page, let's move. Okay, expanding a logarithmic expression. Guys, expanding a logarithmic expression typically means that when you expand something, you're writing one logarithm as multiple logarithms. When you expand it, it's what? Yeah. Okay. Help me, kids. I have the natural log of 3x over y. How might you choose to expand it? Well, first of all, 3x over y. Is that a product? Is it a quotient? Or is it a power? It's a quotient. So how are you going to rewrite this? Anybody? What's in my numerator? What's in the numerator here, kids? Okay, so this is going to become a natural log of 3x. You said it's a quotient, right? So use your quotient property. So you're starting natural log of 3x minus natural log of y. Boom, done. Nice job. Okay? Oh my goodness. If expanding a logarithmic expression means start with one logarithm and write it as multiple logarithms, whether it's adding or subtracting or multiplying, then condensing must mean what? Make it into one. Take multiple logarithms and try and rewrite it so it's down to one logarithm. Now let's think about this, kids. There was something I was going to say. Condensing, going from multiple logarithms down to one logarithm. The word condensing might be like the word that we use a lot in mathematics. It starts with an S. Condensing means basically simplify, okay? Condensing simply means simplify. So condensing a logarithmic function. Let's talk. The first thing I have here, what are you going to assume our base is? I don't see a base up there anywhere. Okay. And I think one thing I need to stress, and I've probably done a poor job of this, but one thing I need to stress is when you do this stuff, it's very important that on all of these right here, like how many logs do you see up here? Very important that the bases match. So if I look at the three logarithms, do the bases match? They're all the same. It's a common logarithm. We're going to assume the logs on each of those three up there is what? 10. Okay, so here's how this works. This becomes log of 6, and I'm going to rewrite this out again. You may or may not want to, but I want some room to work with. Plus, okay, let's look at this. This is the part I'm concerned about right here. This says what, kids? 4 times the log of 3. Hey, I have a number out in front of the logarithm there. Is there any way I could rewrite that to make that easier for us? Okay, if there's a number out in front, that number basically came from being an exponent that we moved out front, right? So who's to say I can't put it back there to make it equivalent? No one. That's right, no one. So I could call that log 3 to what power, kids? Log 3 minus log 3. Okay, let's talk, kids. What is this 3 to the 4th power going to equal? What does 3 to the 4th power equal? 81. Okay, so help me with this. We end up now with the log of 6 plus the log of 81 minus the log of 3. So help me out here, kids. When we have multiple logarithms with the same base, the first thing that I see right here, kids, is the following. I see that the log of 6 plus the log of 81 is there. How could I take the log of 6 plus the log of 81 and write that as one logarithm? What would you do with the 6 and the 81? Multiply, okay? Then, after I've multiplied the 6 and the 81, now I see minus log of 3. So I can take 6 times 81 and divide it by 3. Okay, so you're telling me right here that this is equal to the log of 6. Come on, pen. 6 times what? Over. Okay, somebody run 6 times 81, divide 3 for me. Hopefully you get 162. So this is really the same as the log of what value? So this is really the same as the log of 162. Okay, that's good critical thinking there, kids. First thing we did, where did this 4 move to? Move to an exponent. If it's out front of a logarithm like that, make it an exponent for this value right here. So we said, okay, this is really the log of 6. 3 to the 4th was what value, kids? 81. So guys, since we're doing log of 6 plus log of 81, this became 6 times what, kids? 81. And then when you subtract the 3, this became divide by what? 3. So those 3 logarithms condensed down or simplified into one logarithm is the same as log of what value? Okay, 162. All right, so we're going to see stuff like that, and I'll help you through this stuff, all right? So the next thing that we're looking at then is what's known as a change of base using common logarithms, okay? We've done this already, which is really cool. It says the log base c of a is equal to the log of any base, which we're going to call 10, of a divided by the log of any base divided by what, kids? C. So here's the deal. If I wanted to evaluate log of, and we did this already, somebody give me a base other than 10. 9. Okay, log base 9 give me a value between 70 and 200.
200.
Okay, so if I wanted log base 9 at 200, okay, I could simply say, you know what, and how did we handle this in the quiz or in previous sections? How did we evaluate this? This is the same as 1 over what? In your calculator, log 200 over log 9. This is the same as log. And when we don't put a base down here, we assume the base is what value? 10. So we're going to assume 10 right here. Log base 10, 200. Over what, kids? And again, the assumption is if I don't see a base as a subscript where the word log is written, the assumption is there's really a base of 10. So go ahead and do that for me, kids. If I wanted to know just type in log 200 divided by log 9. Tell me what you have. 2 point. Okay. All right, so this is not really new right there. It's just called change of what, kids? Change of base formula. Okay? So you guys just make sure we're good on this. You guys evaluate on your own. Evaluate log base 7 of 11 using common logarithms. And when I say common logarithms means your base is 10. So that's just the button in your calculator. Okay, so tell me what you guys get. Make sure you agree. Log base 7 of 11. See what you get when you hit that in there. Show of hands when you have it. Ellie, what'd you get, kiddo?
0.81.
I'm here getting 0.81-ish. Is that what you got? Log 11 divided by log.
Oh, I did log 7 divided by log.
All right, do it up. I'll do it the other way. Okay, so log of 11 divided by. Yeah, tell me what you got now, kiddo.
1.23.
How many like 1.23 better? Okay, good. All right, simple mistake. So, kids, this log base 7 of value 11 is the same as what over what? I have a question for you. This is the same as the log of 11 over, whoop, come on, pen. I think my pen is slowly dying. Log base 11, log 7. What'd you say again, Ellie? 1.23, was that what I heard?
Yeah.
Okay. So I think you guys should have a handle on that. We've looked at some of that, and I think that you guys, honestly, I think you guys do a really nice job at that. Okay? So example 5. It says evaluate log base 2 of 19 using what? Okay. It's don't freak out about this. okay? Instead of using your log button, they're just telling you to use which button? So what you would do here is this. You would use your LN button. So, guys, is my base E down here, or is it something else? It's 2. So I would say to evaluate log base 2, we could say that, well, you know what? This would be the same as the natural log of 19 over the natural log of what? See what you get there. I'm going to pull my calculator up here. I'm going to check this. I want to make sure that this is right. That's what I came up with. It's the same if you use what? Yeah, if you use logarithm, if you use the log button. Okay, I'm getting 4.248. You guys agree? Okay, I could have done the same thing if instead of using the natural log button, I could have gone log of 19. Oh, help me. Where's the log button at? Where at? Way down there. Yep. Log 19 divided by log 2. Same thing. So change of base. Does it matter which logarithm you use? No. What do we get for a value here then, kids? 4.248. Now I'm doing a lot of talking. Either A, you're not awake, or B, you're accustomed to 2-hour delays and you're really not awake.
Yes. Yeah.
Or all of the above. Just give me a show of hands. How many got 4.248 out of there somehow? Okay, so we're good on change of base for a minute. All right, so let's take this and let's apply this. Anybody need more time? Page 2? Back corner, you guys okay? Boys back good? Got everything? Everybody in the middle here, got everything? Wall people, all good? Wall people. All right. Ooh. This looks kind of tricky. Solving a real life problem. How about a volunteer to read that for me? There's a lot of big words in this. I love it when they throw big words in there to try and confuse us. Thanks, Jasmine.
For a sound with intensity I in watts per square meter, the loudest L of the sound in decibels is given by the function L of I equals 10 log, and then I over I to base 0, where I of base 0 is the intensity of barely audible sound, about 10 to the negative 12 watts per square meter. An artist in a recording studio turns up the volume of the track so that the intensity of the sound quadruples. But how many decibels does the loud sound increase?
Oh my goodness. So this I of 0 right here is like an initial value. What is that initial value again, kids? Ten to the negative 12. So we have a function up here, kids. We have a function up here. And in our function, we know that I of O, or the initial value, is 10 to what power? Whoops, 10 to the what? 10 to the negative 12, you bet. Okay. We need to find, well, what are we going to do to the sound, kids? You're going to quadruple it, right? You are going to quadruple it. Thoughts on this? Any thoughts on this? Well, it's actually pretty simple. It says For a sound with the intensity I, the loudness L of I is given by the function L of I is equal to 10 log I divided by I sub O, where I sub O is the intensity of a barely audible sound, about 10 to the negative 12 watts per square meter. An artist in a recording studio turns up the volume of the track so that the intensity of the sound does what? Quadruples. Okay? So the intensity quadruples. I don't know what it was before, but what could you probably put in for I? 4, right? Okay? I put a 4 in there for I, so I think that this is what you should do. Simply going to put 10 to the log of, what do you want to put in here, kids? If you want to quadruple this, I don't care what it is, what could you put in there? 4, okay? What's 10 to the log of 4 equal? How much?
6.02.
So this is going to increase by about about 6 decibels. Yee. Well, that seems pretty simple. You guys want the long drawn out explanation here? I'm going to tell it to you. Okay. What was the initial volume here, kids? Okay, here's how this is going to look. You guys agree that we have a 10 out here, right? I'm going to leave that 10 out here as the front. Or I could move the 10 where if I wanted to. Okay? So what I could do is say, well, I could call that 10 out there, but I'm going to leave it out front. I could call this 10 log of I minus 10 log of what value here? I of what? Okay. Now again, this is what we started with initially, right? And we're going to turn it up so this turns into what, kids? 4 of them, right? We want this I really right here to be 10 times the log of 4 times this value. So 4 times I sub O minus, oh my gosh, this is getting crazy, 10 log I sub O. But kids, what is I of O value? What's the I of O value here? 10 to the negative 12. So I could plug 10 to the negative 12 in here and 10 to the negative 12 in here. So I could have 10 log of 4 times 10 to the negative 12. Whoops. Minus 10 log of 10 to the negative 12th power here. Okay? Now watch what I do here to get to this part. I'm going to get me some room here. When I have this minus part right here, I can put this back as division. Okay, so this could really become 10. I'm going to move my work down here because I have the answer. This would become 10 log of, we want to take this 10 to the negative 12, the initial sound, and do what to it again, kids? Quadruple it. So this could be 4 times 10 to the negative 12 over 10 to the negative 12 when I take this subtraction and combine it. But guys, what would the 10 to the negative 12s do right here? So again, this becomes 10 log of what value? which is about how many decibels? That's a tough problem, okay? That's a tough problem. You got to understand that I is really 4 times the initial value because you're trying to quadruple that, okay? So we run into stuff like that. We'll work together on some things there. That's pretty tough stuff. So I guess for you guys, do you have everything down right now? I'll wait for you on that one. I'm going to go ahead and stop this here.